And so in order to start with that is my turn function, I'm just going to go down here and write a function definition. And this function is going to be pretty easy. At this point, I should have access to two pieces of information. The first one is I should know what turn it is because I'm keeping track of the move number in my script. And I should know what color I am. So for example, if I'm white and the move number is number 1, then I know that it's my turn. If I'm white and the move number is number 3, I also know it's my turn. But if the move number is number 2, I know it's black's turn because basically black goes on even number moves and white goes on odd number moves. And so what this function is going to be, it's just going to be a one-line function. And the one line is going to be this. Now, the first part of this is just some Boolean checks. The first one is I'm going to check if I'm white. And in here, in these parentheses right here, I just check if I'm white. And if I am white, then I check if I'm on an odd number move. And if I am on an odd number move, then that means it's my turn. So I want this whole function to return true. So this would evaluate to true if I was white and I'm an odd numbered move, which means it's my turn. The other way that this could be true is if I'm not playing white, in other words, I'm black, and I'm on an even number move. That would also mean that it's my turn. If either of those two things are true, then I would just return that value, and that is it for this function. That is a simple function that just checks if it's my turn. Now, the next function that I need to do is the listen for move function. And so I'm also going to go down here, and I'm going to add a function definition for that as well. And this function is going to look a lot like the function that I created for the speech to text video. It's going to look, I'm just going to actually copy and paste all of that code because if you watch that video, you should know what this code does. And if you haven't watched that video, I'm going to link it at the top of this section in the video, as well as in the description. So go check it out if you haven't seen it. But the TLDR is, it's going to be one big while loop while this function continuously listens for my move. And it will try to use the microphone to get audio. And it will just do some preparation. This function just does some preparation in advance. And if you want to know what this does in more detail, just check out the video. But essentially, once we get to line 139, what happens after it turns on the microphone and you speak, this my text value should now have a string that contains whatever phrase you said. So we're going to print that phrase for the user to see. And then we're going to use our speak text function that we wrote earlier to say the phrase out loud so that the user, because of course, they're blindfolded, they know what they said, or at least they know what the computer interpreted that they said. And so once we have that, the next thing that we need to do is we call this other helper function that we need to define. And all this function does is it looks at my text and it just makes sure to see that what we just said could be a valid move. And what I mean by that is it needs to be in the form of a specific phrase. We don't want people saying just anything and accepting it. For example, if I just say bananas are yellow, then that's not going to be helpful to proceed forward. And so this function is just going to make sure that the string takes the form of one coordinate and then space and then the word to and then space and then another coordinate. So for example, something that would be acceptable by this function is E2 to E4 or E2 to E3 or D2 to D4, whatever move you can do on the board. It would also accept something like A1, which is a rook, all the way to A8, which would be an illegal move on turn 1. This function here does not check for whether or not the move is something that's legal. It just checks if it's of the form one coordinate and then the word to and then another coordinate. And if it is of that form, this listen for text function will finally return it. And again, we don't need to check if the move is a legal move because later in the code, we have a check for that. So we just need to make sure it's a possible move. And if it's not a possible move, we will simply ask the user to repeat what they just said. And since this is in a while loop, we will go back to the top of the while loop and it will try again. Whereas if it is a valid phrase, then we will just return my text. And that's it for this function. This is valid move phrase is kind of easy to define. I'm just going to paste the whole function here. I'm not going to go through it in its entirety because I don't think it's super necessary to do so for the point of this video. But here's the function. Essentially what it does is it splits up the phrase into some words. Basically, hopefully it should be 3 words because it should be of the form 1 coordinate space the word 2 space another coordinate. So we split it up into an array of words. Hopefully that array is of length 3. Then we define valid columns and rows. And the first word, we grab it and we grab the third word. And we just make sure that those 2 words are of length 2, meaning that they should have 2 characters in it, which would make sense if it's of the form A1 or E2 or something like that. And what we do is we see if that first character in the first word is in the valid columns. So we want it to be a letter ranging from A to H. And we make sure the second character in the first word is a number ranging from 1 to 8. And we do the same check, same exact logic for the third word. And if all of that is true, we return true, this is a valid phrase. If it's not, we return false. Pretty simple function. It just checks to make sure it's of that form. And with that, this listen for move function is now complete. And we can move on to the next function that we have for our helper function, which is actually to finally make the move. And this function is going to be probably the hardest function of the helper functions, but it's not going to be too bad. So the first thing we're going to do is we're just going to, once again, write the function definition. And at this point in the function, we are going to have the move, which again is just going to be a phrase. So we're going to have to dissect that phrase in a way that the Chrome browser will be able to understand. And so I'll just add this code right here. And this is basically that dissection. So I get the move. I split it up into an array, which is basically, since we know it's of length 3, if we made it this far, it'll just be an array of length 3. We can get the first word and the last word, which should be of the form A1 or B2 or something like that. And once we have those, we can actually make coordinates out of those. And the reason we have to make coordinates out of those is because if you look at the HTML code on chess.com, you do the right-clicking link that I showed you earlier. These coordinates, the HTML for these coordinates do not take up on the form of A1 or B1 or anything like that. They actually take on the form of 1, 1 and 2, 2. So E2 would actually be 5, 2 because 5 is the 5th letter of the alphabet, and then the 2 would be the number. And so what we would need to do is we would need to change the entry that we just said. So for example, if the move that we received was E2 to E4, we would need to change that to 5, 2 to 5, 4. And so this is just going to basically be another helper function that we need to write that does that process for us of converting a coordinate like E2 to 5, 2 so that we can use it for the rest of the script. And I will write that later once we're done with this function. But basically, once we have that in that form, we can grab the y coordinate, which is the first character. So in this case, if the move that we're making is E2 to E4, it will be converted to 5, 2. And so start would be equal to 5, 2, and end would be equal to 5, 4. And so at that point, we get the first character, which is the y coordinate, which is in this case a 5. So start y would be equal to 5, and start x would be equal to the second character, which is 2. End y would be equal to 5, and end x would be equal to 4. And basically, this is just the x and y coordinates on the chessboard for the move we want to make. And so once we do that, we can actually get the delta and the y direction, which in this case would be 0 because we're moving from 5 to 5. And the delta and the x direction would in this case be 2 because we're moving from 2 to 4. And at that point, once we have the x delta and the y delta, we can actually finally try to move the piece. So the first thing that we need to do is we need to use that same find element function to try to find the piece on the chessboard. And so here I'm going to do exactly that. And so now that we have these coordinates, we can use the starting coordinate to try to find the piece, because that's where the piece should be ideally. And so what we do is we try to find the element that has a chess piece on this square. And this is the HTML code that you would need to write in order to attempt to do that. Now, if there is a piece there, this function will find it, and it'll put that web element into this piece variable. However, if there is not a piece there, then this function will throw an exception. And in that case, we want to tell the user that there's no piece there anymore, and we would want to exit out of this function by returning. And that's it. So, we would continue on in the event that we do find a piece. What we want to do is we want to do a series of actions. So in this case, we're going to instantiate this actions chain, and we're going to store it in this variable so that we can do our sequence of actions. The first action that we want to do is we want to click and hold the piece. Just like you would if you were actually moving the piece, this function right here will just click and hold onto it. The second thing that you want to do is you want to move the piece. And so in order to do that, there's this function called the move by offset function. And this does what it sounds like it. Since the piece is already clicked on, you're now going to move your mouse by a certain amount. And now that we have this x delta and y delta, we can indicate to the function exactly how much we want to move it. And the way it would look like is it would look something like this. And this is a little complicated, but essentially what this is there's an y distance that you want to move it here, and there's an x distance that you want to move it as the second parameter here. And these are measured in pixels. So what you need to do is you need to get the number of pixels that you want to move it by. And so you know that you might want to move it by y delta number of squares. So in this case, y delta is 0. In the case that we want to move from E2 to E4, so this whole thing would be 0. But for the x direction, it would be 2. Well, obviously, you don't want to move it by 2 pixels. You want to move it by much more than 2 pixels, but you want to move it a total of 2 squares. So at that point, you need to find the number of pixels that one square takes up. And you can do that by finding this width attribute of the piece, because the piece takes up the whole square. And so if you find the width attribute, that actually gives you the number of pixels that one square is. And so by taking that width and multiplying it by the x delta, you're effectively telling the function you want to move it by exactly 2 squares. And I also have this multiplier here. The reason I have this multiplier here is because of a bit of a gotcha. Basically, the board, remember, is flipped when you're playing the color black, and it is not flipped if you're playing the color white. So these values are going to be inverted depending on whether or not you are playing black or white. So you're going to need this multiplier variable here, and you're going to basically set it equal to 1 if you're playing white. If you're not playing white, you're going to set it equal to -1, just so that you're basically moving the piece in the right direction. You're either moving it up the board if you're white or down the board if you're black. And that multiplier variable kind of takes care of it for you. And so that's why we add it here. We also have to multiply the x direction by a -1. It's just kind of how they structured the board. So it's something that you just have to put in there. But at the end of the day, really what you need to focus on is you're moving it by a certain number of pixels. You're doing it either x or y delta number of times. you have this multiplier to cover the case of whether you're black or white. And that action should, in theory, move the piece. And once you do that, remember at this point, you've only moved the piece. You actually have to let go on the mouse. Otherwise, the move would not be complete. So you need to do this action.release function to actually let the piece go on that square. And now that you've finished creating your action chain, you run this action.perform to perform all of those actions that you just added to that action chain. And once this runs, it should move the piece, which is great because that should also complete the make move function. Now, if it was able to find a piece and line 184 did not throw an error, and we made it all the way down here, but still nothing moved, what that would mean is that you just tried to grab a piece and you tried to drag it over to a square, which is not a legal move for that piece because it did find a piece, but it wasn't able to move it there. So for example, if you grabbed the king and you tried to move it like a bishop, all of this stuff would execute, but it would do nothing. What would happen is later on in the script, we would check to see if a move was made. And in this case, a move would not be made, and it would try to make another move by listening to our audio input in order to make a move again. But that does complete this function. The only thing I need to do is define this convert coordinate function, and I'm not going to go into too much detail on that. I will just show you here by pasting it over here. This is what the function looks like. You don't need to know too much about it. All it does is it converts something like A1 to 1-1 or E2 to 5-2. It just takes the first character, it turns it into an ordinal, basically a whole number. And I believe it corresponds to the ASCII number that represents that character. So I think that the character for A, I believe that that is the number 97. So if you have the number 97, you subtract the number 96 from it, then you should get the number 1, and it converts that into a string. So basically, if you had the character A, this section of code would return the number 1. If you had the character B, that would translate to the number 97 right here. It would translate to the number 98. 98 minus 96 would give you the number 2, and then you'd have the string 2 right here. So if you had something like B1, it would become 2-1. You don't really need to understand this too much. It's not really the point of this tutorial, but just so you have it here for completeness, this is the function. It just takes the coordinates and converts them, as I said before. And with that, your make move function is complete, and there is only one more helper function that you need to write, and that is this player has moved function. And this function is to just make sure that the current player has made a move. And so this function, I'm going to start it as the last helper function, and it is just going to have a similar function definition. And of course, the natural first thing to do with this function is to attempt to get the web element that indicates that the player has made a move. And so in order to do that, what I did was I looked at the chess notation that's on the side of the chessboard, and I checked to see if, that player has an entry for the current move number we're on. And so I do that by using the find element function, and the HTML takes on this form. The data-ply value is just equal to whatever the move number is. So there's going to be a data-ply value of 1 once the player makes the first move. And so, if it's your turn, let's say you're playing white, you just try to make your 5th move. When this function runs, it's going to check to see if data-ply equals 5 exists. And if it does, that means that you've successfully made your move, and that's fantastic. And if it doesn't, it means that the player has not moved. So as you could expect, if this function does not find the piece, it will throw an exception. And all we need to do is we need to just inform the player that they have not moved, and we return false. the player has not moved, and so this function can safely return false. Now, you might return true here, but instead of returning true, there's one more thing we have to do. Once the player is moved, we need to also make sure the game is either over or not over, because this is the point where we would look for whether or not checkmate just happened. So the first thing that you're going to do is you are going to get the English pronunciation of this piece. So when you do get this HTML code and you find this move has been made, you can try to get the chess notation and you can try to interpret it in a way that would be understandable in English. And the reason we do this is because whenever a move is made, remember, if your opponent makes a move, we need the machine to tell us. So if the opponent makes a queen move, we would need to know what that move is. And we would want the computer to tell us in the form of something like queen to e2 or rook to b5. And so the first thing we need to get is the English pronunciation of the piece that was involved in this move. So I made another helper function, which is just this get piece function. And all it does is it gives us the English word for the piece. I'll show you it later, but right now it's not important. So moving on, once we have that English pronunciation of the piece, then we are going to print it. We're going to print that piece, and we're also going to print the move text, and that is just the chess notation for the move that we found up here. And once we print those two pieces of information, the next thing we do is we just run this speak text function to tell the user what the move was. So for example, if the English pronunciation of the piece was queen, then it will say something like queen to b5, if that's what the move is. And that's what this function will do, and that's perfect because that's what we need. It'll do this whether or not it's our opponent's turn or if it's our turn. It might be unnecessary for the computer to say it if it's our turn, but it is kind of useful because if you make a move, you're just getting a confirmation from the computer what the move you just made was, which is handy. Now, the only thing that's left to do in this function is to check whether or not checkmate was made. And so we're going to do that before this speak text function runs, because if checkmate was made, we're going to want to say something different. And so I'm going to paste the code here. And the way we want to see if checkmate was made is see if this pound symbol was in the move text. And if it is, then we know that some player has just checkmated their opponent. In order to figure out which player, we just need to check whose turn it is. If it's our turn, then the winner is the player. And if it's not our turn, the winner was Martin. And once we get the winner, we can run this speech text function over here. And essentially what this will do is it will tell us who won. It'll say it out loud. So it'll say something like queen to whatever the move that they made was. And then it'll also say, in addition to that, checkmate. So it'll say something like queen to b5, checkmate. Player wins, or Martin wins. And that's the phrase we want it to say. Whatever the move was, so it'll be like bishop to b2, checkmate, this player, Martin, or the player wins. And that's it. Once that happens, we want to change the game over flag to true, because now the game is over. And we want this function to stop running. So to get the function to stop running, we can return true here. And we can also return true here as well. And that will stop the function, and that indicates that the game is over. And that is all of the helper functions. The only thing left to do is to write the definition for this get piece function. And I'm not going to spend too much time on it, but I will show it to you. And here's the function. And remember, this input here is the web element of the piece. And so the first thing we try to do is get piece info from that piece. Now, the way that the HTML is defined, if it's a pawn, we will not find this piece info associated with it. And the reason for that is because inside of the chess notation, they don't have a symbol for the pawn. They just write b4 or e2 or something. And so there's no piece info associated with that in the chess notation on chess.com. But if the piece that's moved is a major piece like the knight, the bishop, the rook, or the queen, or the king, then it will have a symbol for that. And so basically this will throw an error if we're trying to get the piece info for a pawn, but any other piece will be able to get it. And so in the event of an exception, instead of trying to get the element, we just get the text instead. And so we're gonna, after that, we just assume that the piece is a pawn, and we check to see if piece info is a web element, meaning if it's a web element that this succeeded. If it's not a web element, then we just got this move text variable, which is a string. So if it's a web element and this succeeded, we know that we don't have a pawn, and so we need to update this piece variable by getting the piece info and getting the data figurine attribute. And we just convert that attribute to an actual piece, because this line right here will spit out something like a capital Q or a capital R, meaning queen or rook, but obviously we don't want Q or R, we want it to say the word queen. So this dictionary right here is something that I am going to also add to the init function, just to map these letters to these pieces. And so I just added the dictionary here, and it just makes this mapping of these letters to these pieces, because that is how chess.com uses these letters for these pieces. And so going back to the get piece function, it is now complete. It will get the human text for that piece. If it's not a pawn, it'll put a word like queen or king in there, and it will return that string, which is what we want. And so that means the get piece function is complete, which means the player has moved function is also complete. And that should complete our entire script, which means if we were to run this script now, it should work. And so I am going to test that by running it right now.
You are black. Pawn to d3.
d7 to d5.
d7 to d5. Pawn to d5. Pawn to a3.
c8 to f5.
c8 to f5. Bishop to f5. Pawn to b4.
d8 to h1.
d8 to h1. Invalid move.
Bananas are yellow.
Bananas are yellow. Can you repeat that?
g8 to f6.
g8 to f6. Knight to f6. Pawn to g3.
And there you have it. It looks like the script is working. It looks like it's dealing with invalid moves properly.
And there you have it. It looks like the script is working. It looks like.
And it's still listening to me. I'm going to turn it off now. And there you have it. The script, it looks like it's working. It's dealing with invalid moves properly. It's moving pieces when I ask it to, and when the opponent makes a move, it's telling me what the move is. That is basically the script that will allow you to play chess on chess.com blindfolded. I hope this was helpful. I hope it wasn't too terrible to watch this, and I hope that you got something out of it. Thank you so much for watching. I really appreciate it. If you like this content, please comment and let me know. Let me know if you want to see more stuff like this, or if you want to see me make different things. Still new to YouTube, so I'm still kind of getting my footing. I appreciate the support. Thank you so much. Goodbye.